All right. So number 9, I'll just write them out real quick for you. Number 9, I got 2x minus 1 and x minus 2. Oops. Questions? All right. Number 10, I got 2x squared minus 1 and 4x minus 3. Okay. That one was already 4 terms, so just group first two, last two, pull out your GCFs. It works out pretty easy. Number 9, we had to go 2 times 2 and use -1 and -4 to write your -5 and turn it into a grouping problem. Number 11 is one of those difference of squares, 5x plus 1, 5x minus 1, square root of 25x squared and square root of 1, right? One's a plus, one's a minus. Number 12, a was 1, so it's just the factors of 36 that add up to -12, which was what? X minus and x minus 6 and 6, huh? So I could have done the 1, 2, 3 test, right? And put x minus 6 squared. One of those special trinomials. Number 13, any questions on 9 through 12? We okay? 13 was x plus 1 and 3x minus 1. And 14 is x minus 1 and 5x plus 2. And 15, pull out the x. And then it's one of those special ones that you could do the 1, 2, 3 test. Or if you just wrote x plus 1 times x plus 1 after you pulled the x out. Okay. 16, pull the 2 out. It's got a GCF of 2, and you get x minus 6 and x minus 8. Factors of 48 that add up to -14. Because you're pulling a 2. So that becomes x squared, that's 14x, that's 48. We good on that group of 4? Questions? I can go through the whole thing if you need me to. All right. The last 4, multiply 4 times 3, you get 12. To get -13, you got to break it up into -12x and -1x for a grouping problem. And then it's x minus 3 and 4x minus 1. All right. Number 18, it's already a grouping problem. There's no GCF for all of them. So when you group it and you pull out GCFs, after you group it, you get 2x plus 1 and 3x squared plus 4. For 19, there's no GCF. When you multiply 8 and 3, you get 24. Split up the -10x into -6x and a -4x. And when you do that, you have a 4x minus 3 and a 2x minus 1. And then the last one, it looks like a difference of squares, right? But is it actually a difference? Difference means what? Subtract, right? This is addition. So this is not factorable. Okay, can't do that. No questions? You guys are okay with those? All right, so back to the warm-up. That one's, first one's pretty easy because A is 1. What are the factors of -21 that add up to -4? -7 and a +3, right? So you can just do that. Whatever works for -21 and adds to get -4, then you're done. For 2, we're going to have to go no GCF. Again, I'm thinking that. but there isn't one. So I multiply 6 times 4 and get 24. And the factors of positive 24 that add up to negative 11 are negative 3 and negative 8. So I'm going to rewrite it as 6x squared minus 3x minus 8x plus 4. And then I'm going to group first two, last two. Let's put a little plus sign between. I keep that negative sign in front of the 8 in my group. And then I pull out the GCF. So 3x is the GCF for those two. And I get 2x minus 1. Since there's a negative in front of that 8, I'm going to take out the negative sign, and 4 goes into both of those. And I get 2x minus 1 again. So my answer is 2x minus 1. I wanted those two to be the same. And then 3x minus 4, those GCFs. So I'm going pretty fast, but that's what we've been doing on those. Any questions? How I did anything? All right, number 3, is there a GCF? Some go into both of those? No. So it's got two terms. Are they both perfect squares?
Yes.
Yeah. Anything to an even power is a perfect square, right? And 4 and 25 are perfect squares. So it's one of those difference of squares. So we make two sets of parentheses. Square root of 4x squared, or 4x to the 6th is 2x to the 3rd, right? Just cut the exponent in half. What's the square root of 25y squared? 5y. And then one's addition and one's subtraction. And we don't have any difference of squares left to go further on that. And then number 4, the GCF is 2, right? 2 goes into all 3 of those. So when I divide 2 out of there, I'm looking for factors of 14 that add up to negative 9, which would be a negative 2 and a negative 7. When I multiply those, I get positive 14. And when I add those, I get negative 9. All right, so factoring, we're going to be doing a lot of that once we start chapter 3 tomorrow. Okay, so we're going to need those methods to help us solve these quadratic equations we're going to start solving. Okay, now before we get into chapter 3, we're going to simplify some radicals too. All right, so you guys should be able to do this, but we're going to review anyway. When I simplify a radical, okay, I don't just put it in my calculator and get 3.4 or whatever it is, okay? I do a factor tree. What are the factors of 12? You can go 6 and 2, 3 and 4, doesn't matter. 1 and 12, no, you don't want to do that, okay? I would do 3 and 4, and I would stop there because I know 4 is what type of number? A perfect square. So I know that the square root, this is the same as this times this, right? We just don't write those radical signs. All right? What is the square root of 4? 2. So I can pull the 2 out front. I can't break 3 down any further. There's no more perfect square factors left. So I just leave it underneath. So I would want you to write square root of 12 as 2 times the square root of 3. Okay? You guys remember that? That's what we're doing with simplifying radicals. All right? So, Jordan, how would you start 80?
I would do an 8 and 10.
Okay. Oops, I was going to make another tree branch. Okay, how would you do 8, Jordan?
I would do 2 and 4.
Okay. And 10?
And 5 and 2.
Okay. I would stop there. I know 4 is what? Perfect square. Also, There's a pair of 2s. We're looking for pairs of the same number. What is 2 times 2? 4. Another perfect square, right? So for the circled 4, what number can I pull out? 2. For the pair of 2s, what number can I pull out? 2. And I multiply whatever I pull out. And then what's left underneath? 5. So this would reduce or simplify to 4 times the square root of 5. You guys with me on that? So it doesn't matter how you start. You could have done 4 times 20, right? You could have done 16 times 5. That's how I would have done it, because I know 16 is what? A perfect square. So then I just would have had 4 radical 5. Okay? But it really doesn't matter how you start your factor tree. If you go all the way down, we call these, if I kept going down here, I would have just, got a pair of 2s, the other pair of 2s, right? We call that the prime factorization. The factor tree goes down to its prime factors. Prime factors are numbers that only have 2 factors, one in itself, okay? So it doesn't matter how you start your factor tree. You're just looking for pairs of numbers, okay? And then for each pair, you pull that number out. Whatever you pull out front, you multiply. Whatever's left underneath, you multiply. There was only one number, so there was nothing to multiply the 5 by. But if there was like a 3 in there, also I would have made it a 15. You follow me? Any questions so far? Bless you. So I would do and stop. Why? 100's a perfect square. We all know that, don't we? What's the square root of 100? 10. So what's my answer? I heard somebody, Brock? Yeah, 30. What's already out front? 3. So the 10 that I bring out, I got to multiply by the 3 that's already there. Does that make sense? Any questions? Cindy, how would you start this one? 5 and 10, okay? How would you do the 10? 5 and 2. You see a pair of anything? Yeah, 2, 5. So what's our answer?
Negative 20.
Very good. What's left? Well, the 10 we broke up, right? So it's just the 2, yeah. You guys okay with that? Questions? Yoder, you all right? Wolf, you all right? Okay. No questions. Making sense? Vince, you got a question?
Yeah, just I'm trying to remember it.
Which, do you understand that I circled the 5s because there was 2 of them?
Yeah.
Did you? So I went 5 times 10, and then the 10 breaks down into 5 times 2. All right? So once you break the 10 down, you're not going to look at it anymore. All right? So I see 5, 5, and 2. Since there's 2 5s, I can pull that 5 out front, and there's already a 4 there. So when I pull it out, I got to multiply.
Okay.
That's where that negative 20 came from.
All right.
And then the 2 was left, so I still got to leave it underneath. Okay? Anybody else? Okay. So we're pretty good. Those are just the basic ones that are pretty straightforward. Right? Sometimes they give us fractions. Okay? So you can think of it like this if you want, as 1 in the top and 1 in the bottom. If they had a common factor, if there was a number that went into both of those, I would reduce that fraction. Right? But there's no number, besides 1 that goes into both of those, right? Now, in algebra 2, or algebra 1 actually too, in algebra, you're not allowed to have an irrational number in the bottom. Okay, the square root of 5 is an irrational number. All right, so we have to rationalize the denominator. No radicals in the bottom. The way we do that, when it's a square root, we're just going to take whatever that square root is and multiply that fraction by whatever that square root was over itself. What is anything divided by itself? 1. So I'm basically just multiplying by 1, right? And if I multiply something by 1, I get the same thing back, right? It's just going to look different. All right? So what's the square root of 3 times the square root of 5? Square root of 15. What's the square root of 5 times the square root of 5? What kind of number is 25? Perfect square. So we know the square root of 25 is what? 5. So now, some kids think they should divide that 5 into the 15. Can I do that? No, they both have to be under the radical sign for me to divide that 5 into the 15. Or, if I had a number out here, out front, that 5 and it would go into, I could do those. All right, but I can't do stuff that one's inside and one's outside. I can't divide or I can't multiply either. They both got to be under the radical sign to multiply them, like I did here, or both out front of the radical sign to multiply. Okay? So that's called rationalizing the denominator. All right? Questions? Again, most of you can go from this times this to that. If this, basically we're saying the square root of 5 squared, right? What's the square root of something squared? Have you heard that? Itself. Right? Basically the square and the square root do what to each other? They cancel. So that's what we're doing there. So you don't have to put this radical 15 over this radical 25. You can go right to the radical 15 over 5 if you want. Save you a step. Understand what I'm saying there? Okay. Mr. Collins, what should I do with this one?
Same thing will be.
Yeah, multiply top and bottom by what? Yeah, square root of 2. So what's the answer, Kevin?
Top is 14.
Square root of 14.
Square root of 14. Square root of 4.
Right? And the square root of 4 is? 2, right? Now we got rid of the radical in the bottom. We rationalized the denominator. Making sense? Okay. This is a little bit nicer. Why? Why is this one a little bit nicer than the other two we just had? Yeah, the 36 is a perfect square, right? So what I would do is rewrite it like that. Everybody with me? If one of those is a perfect square, simplify it. Now, in order to simplify this radical here, this fraction, I have to do that, right? What's the bottom going to end up being now? 5, right? Now, sometimes you can leave it like that. A lot of times, we like to make that one fraction. Okay? So this is like 3 over 1, right? How do I add 3 over 1 plus 6 radical 5 over 5? What do I have to add two fractions? Common denominator, right? So what's the common denominator between 1 and 5? 5, right? All right, so the original denominator for this fraction on the right was 5. The common denominator is 5. So do I have to do anything to the original numerator? No, that stays. But what did I do to this denominator? I multiplied it by 5 to make it a 5, right? So what do I got to do to that 3? Multiply it by 5 to make it a what? 15, right? Okay, so a lot of times you'll see an answer like this when you have something like that. You can rewrite it. A lot of times when we start solving these quadratics, you'll see a lot of answers like that. Well, you'll have 2 numbers up top and 1 number in the bottom. Okay? One of those numbers will have a radical in it. So this one, no perfect squares, so what am I going to multiply by? What am I going to multiply by? Anybody? Not 7, but radical 7. Yeah.
You have to be joking.
Okay. So this is 5 minus what? Right, square root of 42 over 7, right? Now, if I want to make that one fraction, what's the common denominator going to be? 7, right? Now, can I simplify 42, or is it, is there any perfect squares in 6 or 7? No. So we got to leave it square root of 42. What did I do to the 1? Multiply by 7. So what's 5 times 7? 35. So this would be 35 minus the square root of 42 over 7. Making sense? Question? William? Mason? Making sense to you? Sophia, what would you do in this one? Do I have to multiply by 4? Is it a radical 4 in the bottom? No. Only when it's a radical. But what could I do to that? It's a perfect square, right? What's that? Negative 2, right? What's that? Good. All the way down, right? So, sometimes they'll throw something like that at you and check to see if you're paying attention that that's a perfect square in there. It's okay to have a regular 4 in the bottom, right? We just can't have a radical in the bottom. Okay? Can I simplify that radical 48? How about if I do the factor tree for you? I'm going to stop there. Why? Yeah, 16 is a perfect square, right? So what number can I pull out of there? 4. Is that finished? Is that simplified all the way? No. Why, Cindy? Well, if it was 2 radical 3 minus 4 radical 3, we could do it. I can't subtract the 4 radical 3 from the 2. But look at the 2, the 4 in front and the 4 in the bottom. What goes into all three of those numbers? 2. So you can divide 2 into all three of those to simplify it. You know, just like we did up here, this one was nice because that was a perfect square, but 2 went into 2 and 4, that's why we reduced it to a negative 1/2, right? So we're doing basically the same thing, we just got a radical 3 this time. You don't divide a 2 into radical 3, you look at the numbers that are not under the radical sign. The 2, the negative 4, and the 4. Okay? So when I divide 2 by 2, I get 1. When I divide that 4 by 2, I get 2. And when I divide that 4 by 2, I get 2. So that's what it will reduce to. That will happen sometimes too. When we're solving these quadratic equations using different methods, we'll get answers that'll look like this 2 minus 4 radical, or this 2 minus the square root of 48 over 4, and we'll reduce it to this. Okay? So that's why we're practicing some of this. Any questions? All right, you guys did good. Coming back to you, I hope, from a couple years ago. So I have a worksheet again. Yeah, but they're pretty quick. You could probably get half or 3/4 of it done here before you leave. You got about 10 minutes. Very good.
They say Rob would know that.
You're Robert?
Oh.
What do you mean you're Robert? You did?
His thinking was, bro, it was donated for free.
No, the line is